Welcome students. So in last class we have read the equations of motion. Today we will read another type of motion which is called as circular motion. So what is circular motion? The circular motion is the motion of a body in a circular path. If I will take a circular path here and if the body moves in this path, the motion will be circular motion. So how the circular motion will take place? Just let us do an example, or just do something little different. This is a rectangular path. The body is starting from A to B to C to D, going from A to B to C to D, then to A. So from starting from A, reaching at A, the body will complete one revolution. What I will do, I will just erase this. Now see here, this became a 1, 2, 3, 4, 5, 6, 3, 3, 6 to 8 octagon. Now see here, the body is body will start from this point, will revolve and reach at this point, final point. Again I will just cut and make the edges shorter. Like that, when we will make the edges too short, the body or the path of the body will be circular, and the motion of the body in that circular path will be called as circular motion. Now come to the point, uniform circular motion. We have read about uniform motion, so we will see about uniform circular motion. So what is uniform circular motion? Now if the body moves in a circular path with a constant velocity or constant speed, not constant velocity, with a constant velocity, then we can, with a constant speed, then we can say the motion of the body will be uniform circular motion. We can write, if a body moves in a circular path with uniform speed, then motion of the body will be uniform circular motion. Many students do the silly mistakes. What they will do, or they do that they write that when a body moves in a circular path with uniform speed, it is called uniform circular motion. That is wrong. The motion of the body is uniform circular motion, not it is, because it specifies the body. The body is not uniform circular motion. The body is in uniform circular motion. Let's take an example. I will take a thread, tie a stone in the thread, make the stone to rotate or to move. When I will make the stone to move, the stone will move in a circular path. Clear? The stone will move in a circular path. When the stone will move in a circular path, why the stone moves? Because the thread is pulling the stone such that the stone is bound to move in the circular path. Clear? Because the stone is pulling the body. The thread is pulling the stone such that the stone is moving in the circular path. So the stone is pulled by the thread towards the center of the circular path. The thread is giving some force to the stone towards the center of the circular path. That force is called centripetal force. Centripetal force. This centripetal force is the force which acts along the radius of the circular path. Just see, this is the radius of the circular path towards the center. That means the centripetal force acts on the body which pulls the body towards the center of the circular path. Now my point is, if the centripetal force pulls the body towards the center of the circular path, the path of the body might decrease and the body might fall in the center, because the body will be pulled or is pulled by the thread, but the body is or stone is not coming toward the center. How? Because we know in Newton's third law, it is given that every action there is an equal and opposite reaction. As the body is pulled by the thread towards the center of circular path, some force is there which makes the body to maintain its circular path. That means it pulls the body away from the center of the circular path, such that the body moves or maintain the motion in the circular path. That force which is along the radius away from the center of the body, center of the circular path, is called centrifugal force. Centrifugal, F-U-G-A-L. That means centripetal force pulls the body or acts on the body along the radius towards the center. Centrifugal force acts the body along the radius away from the center. Due to the combination of both the forces, the body maintains its motion in the circular path. Now, when the body is moving in the circular path, what is the direction of the body? Suppose I will make the stone to move in the circular path, and suddenly I will break the thread. When I will break the thread, we will see that the body without moving in the circular path moves tangentially to the circumference of the circular path. It means the direction of the body moving in a circular path is tangential to the circumference of the circular path. So we can write the direction of a body at any point in the circular path is tangential to the circumference of the circular path at that point. Suppose the body is moving in this path. At this point, body direction is this. At this point, body direction is this. Suppose body is moving like this. At this point, body direction is this. At this point, body direction is this. So like that, there is the direction of the body. Now, as the body direction changes always, when the body moves in a circular path, direction is changing means the velocity of the body is also changing, because the direction changes. and after one revolution in the circular path, the velocity becomes 0 because the displacement becomes 0. Okay, now we'll go to the difference between centripetal and centrifugal force. Centripetal, this side is centrifugal. It is a 2-mark question. The first point is it acts along the radius towards the center of circular path. Number 1, this side, it acts along the radius away from the center of circular path. Number 2, it is a real force. Number 2, it is a virtual force. Actually, centripetal force exists. Centripetal force, centrifugal force really does not exist. It is expected to work. Clear? This is a 2-mark question. And remember always, while writing the differences, always write what are different in both, not write the similarity. The points should be opposite to each other, so that you will get the marks properly. So I think this chapter is completed, chapter number 1 of physics, motion. You do all the numerical problems from your textbook, use any reference book, solve the numerical problem. If any doubts will be there, mail me or WhatsApp me or write in the comment box. Also share this video, like this video and subscribe to my channel. Thank you everybody.